Hello students, in section 1.3 we talk about the idea of functions and relations. So what are we actually getting ourselves into? Well, we all know that equations exist and we can come up with almost anything we want to. We can think of anything we want to right now on the top of our heads, 2x minus 7, right? And we know that that represents an equation. We've even learned that we're able to graph these equations. But some equations are special. Some of them have unique features. And these ones that are special are called functions. So the formal definition of a function is, given a relation in x and y, we say that y is a function of x if for each value of x in the domain there is exactly one and only one value of y in the range. Now that's a really kind of just very wordy definition. There's a lot of vocabulary in there. So let's begin to break it down and then we'll go back to this idea of what a function is. So the first word that we saw was domain. Domain represents our x values. It can be called many different things. Different textbooks will use different names. I will most commonly call it the domain or the input. But again, other textbooks may refer to it a little differently. But it simply represents all of your x values that can occur. That means your range is the opposite. It is your y values. And so if domain is input, then range is output. So that's another name for it. Again, there's other names that may be used by other textbooks, but those are not words that I'll use. So just remember domain x, range y. So now back to this idea of functions. In plain English, it's just basically saying that we don't want to see any repeating x values. We only care about the x's, and the x values cannot repeat. That means you can't have 2 3s, okay? You can't have 4 9s. There can be no repeating x values. Now notice it doesn't say anything about the y values. So if you have repeating y values, who cares? That's totally okay, but no repeating x. Every input must have an output. So if there's an equation and I plug in a number, I must be able to get a response. If I don't, there's an issue. So the function machine, this is the idea of every input must have an output. I like to talk about this as like a vending machine. To me, that's the easiest way to kind of think through it. So we all know the concept of vending machine, right? We put in our money and we expect to get a soda out. That's the first idea of what a function is. If I want to get a Diet Coke, I have to put in $1. When I put in that dollar into the machine, I expect to get my soda back. That means every input has an output. Every unique x value, which is my dollar, provides a unique y value, which is my soda. Now, another thing that a function says is that I cannot have repeating x values. When I input my dollar and I get a Diet Coke, I cannot reuse that same exact dollar to get another soda. I must pull out another new dollar in order to get a soda. However, when I pay with $1 and I get a Diet Coke, and then you come over with your dollar, you're also allowed to buy a Diet Coke. So we both can buy the same soda. There can be multiple of the same y value, but each of us had to use a unique dollar or a unique x value. So what do you call it when it's not a function? Well, then that's just a relation. So a set of ordered pairs is a relation. So as long as I have any set of ordered pairs, it's going to make a relation. So, little question for you. Do you think every function is a relation, or is every relation a function? Well, every function is going to be a relation. Functions are made up of ordered pairs. You have x and y values. And so those are always going to be a set of ordered pairs. But it is possible for me to create a set of ordered pairs that does not meet the needs of a function. For example, let's say I make the values 2, 5, 3, 7, 1, 9, and 2, 6. This is a relation, but it is not a function because I have repeating x values. So that can't occur. However, if I make this set of ordered pairs. This is a relation, and it is a function. So if it's a function, it's going to automatically be a relation because you got to have ordered pairs. But just because you have ordered pairs doesn't mean that they meet the criteria to be a function. So there's different ways to talk about functions. We can do it in the diagram form here. We call this a mapping. So I map an x value on over to a y value. And that just shows me that there's some relationship. And this here is defining the mapping. So I'm starting with x and then I'm squaring it. And the squared version is what I get in my y's. You'll notice that I have 4 that maps onto 16, and I have -4 that maps onto 16. So 16 repeats. That's totally okay because I have 2 different unique x values. And then I can also put this into a chart that shows the same exact thing. So I encourage you to pause this video here and sit and try to do this example and answer these questions. Do you believe this is a relation? Is it a function? To list out the domain and to list out the range. So the answer is yes, this is a relation because I can create sets of ordered pairs. I have 1, 2, 2, 3, 5, 4, 5, 5, and 5, 7. Is this a function? No. And the reason why is I have input values that don't give me an output. So I have x values that are not mapped to something, and that's an issue. The domain is going to be all of my x values that are being used. So that would be 1, 2, and 5. And my range is going to be all the y values that are being used, which are 2, 3, 4, 5, and 7. Now, I do want to bring up an interesting point here because you'll notice that there is this 6 that is just floating in the y values. Remember that the definition says every input must have an output, meaning all the x values must be mapped onto something. It says nothing about an output that's just there. It doesn't say anything about its mapping. So it is okay. It does not cause an issue that the 6 is just floating. That's okay that it's there. We don't have no issue there. Let me not put a check mark. Let me put a smiley face. That's okay. There's nothing wrong with that. The thing that causes the issue are this 3 and the 4 in the domain. So just putting it all together, every input must have an output. Some of your y values may not be used, and that's okay. Values of your outputs are able to repeat. Input values cannot repeat. And one input cannot be mapped to multiple outputs. So again, ways I can ask the question to you, you've already seen from a chart, from a diagram, from a list, or from an equation. So just to reiterate, chart and diagram you've seen. Here's an example of a list. I've shown you this. You would say yes because none of the x values repeat, so that's good. And then I can give it to you as an equation. And we'll talk a little bit about that in a later video, how to find the domain when you're just given the equation. Now, one thing that we learn about that's really great is something called the vertical line test. And this is an easy, quick way to determine if you're dealing with a function when given a graph. The vertical line test essentially says to draw a vertical line on your function. So if you look down here at this blue graph, you'll notice that I drew my yellow vertical line. If that yellow vertical line touches that blue function only one time, then I'm good. It is a function. But you'll notice here that it touches here and it touches here. It touches more than once. That means it fails the vertical line test. And it is not a function. So if I hit once, I'm a function. If I cross more than once, I am not a function. As always, I hope you found this video helpful. If you have questions or concerns, please don't hesitate to reach out.